Hey gang, so welcome to Auth, part 2, the authoring. Yesterday was the authoring. So as a reminder, yesterday we were creating users. Our goal for today is figuring out, all right, we've created a user. How do I figure out whether or not somebody is one of those users that they created? So by the end of this lesson, I hope that you will be able to verify a user's identity in Rails, issue them a signed token, and I'm not sure about this third one. We'll see if we get to it, differentiating between authorization and authentication. But first, as promised, let's start by creating a user. You should be able to do this on your own at this point. Go. All right, checking in. Give me a fist to 5. Fist is I have no idea what we're supposed to be doing. 5 is I got a user coming back with a hashed password. All right, Jordan's good. Augie, Gerald, Alex, Alan, Kevin, Christopher. Christopher, what you need?
Just a little more time. I'm not the best typer. I'm just making sure my model is looking good, routes are good, and then I was about to open up my Postman. So just a little, just not the fastest typer.
All right, that's absolutely fine. Kevin Glasgow, how you doing?
I'm at like a 2 right now. Yeah,
Gotcha.
I came in a little late.
All right, feel free to follow along with me. I'm going to Rails new -- API. Auth December 3. All right, so I make my new Rails app. Oops. I go into my new Rails app. I open up that gem file. I uncomment bcrypt. I bundle install. I make sure I got a route handy. So I can post to users, and I'll send that request to users create. What's users create? Well, I can Rails G controller users, plural, and then hop over to that controller, make a create action in it. What goes in the create action? Make a new user. So we'll take in a username. We'll take in a password. It's not password digest here. Password digest isn't what we pass into make a password digest. We just give it the password. I also want to point out that you can put whatever other things, like a full name or a age or an email. You can put whatever else you want on this model also. We can render JSON. Oops. User. And just to be precise about it, I'm going to send back the status code created. That's a 201. By default, it just does 200s for everything. 200 is okay. That's good for get routes, like index and show and stuff. For making something, 201 created is technically more accurate. All right, so I've got that controller. I hop over to my model. Oops, what model? The Rails G model user, singular. Like, how would I model a user? I'm going to run the has secure password macro. I'm going to go over to my migration, which has a username and a password digest. So the model turns the password into the password digest. Sick. All right, I run that migration. I run my server. Fire up good old Postman. And I'm going to send a post request to /users with a username and password and see that I got something good back. All right, so questions about part one?
I feel like I pretty much have it. Mine is saying my action controller, there's a routing error, uninitialized constant user controller.
Okay.
I'm not too sure.
So let's see. Was it, take a look at mine. Was it user controller or users controller?
I'm actually not sure what happened. Everything just is kind of deleted now.
This is good for all of us. Go ahead and screen share. Let's debug it.
I think I was mixing up yesterday's with today's, so I don't. But I'll screen share it though.
Yeah, let's take a look. All right, post users to user singular. We want users plural.
Okay, user.
That one's plural, and the controller name is plural. Yeah. And then over in controllers, I don't think we have the controller yet. So go ahead and kill your Rails server.
Yeah, it looks gone. I made it though.
Nice. Plural.
Users.
You're flying. All right. Open that guy up. So while he's doing that, Rails is magical. It can do things like figure out how to pluralize something or singularize something. It does a lot of good stuff like this. That can also be like a pretty deep source of confusion. So your controllers, plural, your models, singular. If you get them wrong, a lot of the times Rails will catch it and correct it for you, sometimes kind of without even telling you. But you follow that action plan, should be in good shape.
Okay.
Let me see your model. Looks great. Let me see your migration. It looks migrate. Make sure you run your migration. All right, Alex, I have a hunch you've got a one-way trip to Flavortown coming up. Why don't you open up Postman and let's take a look. All right.
And then Rails S, yeah.
Yep, correct.
Oh, sorry. I've been getting a lot of spam phone calls lately.
Me too, man. Like so
Like way more than usual. Okay.
Fire
And then
that
I have.
Oop. Let me take a look at your controller again. User.create username, password. You got the params in there, right? Let me see your migration one more time. T-string username, T-string password digest. So unknown attribute username for user. All right, I want to try something. So here's my hunch. Here's my theory about what happened here. That we Maybe the migration was run too early. So migrations, they don't know that you've changed like a migration that's already run. So why don't you kill this running server, Alex? And here's how you can fix this. So do a Rails DB colon rollback. Nice. And now do your migration again. You're beautiful. All right, so I got username there, password digest, very nice. Try running that, once this fires up. Yeah, try running that Postman hit again. You're
Sweet.
beautiful. All right, Alex, you're good to go. Any other questions about this first step? Very nice. All right, let's talk about part 2. So we've got the user in the database. I go, hey, I'm the one who created the user. How do you prove it? So let's logic through this. Remember, we're not storing the actual password. So how do, like, what could the user do to let us know who they are?
Trying to give us their password.
So they give us their password, but we don't have their password. So how do we know whether or not that was the one they made the account with?
We hash it again. Or
Hash it again. Okay, so what happens after we hash it?
it's gotta like check the 2 hashes and see if it's the same actual end value.
Exactly. Now, the actual mechanism of that is a little bit more complicated than just equals equals. Anybody remember why? Talked about it a little bit yesterday.
Every hash is going to be different, even for the same password.
Even for the same password. Why?
Have different salt.
They have different salt. So how does the salt work?
The Genesis block, it's a whole bunch of information that is added on to the end of whatever your password is.
Yep. So, yeah, well, like, it's simpler than that. We don't need the Genesis block part of it. We can just take the password, we add the salt to it, and hash that. So even though my password is Kyle and Alan's password is Kyle, don't ask me why, we have different salts, so our hashes end up way different after you add the salt to the end of it. Cool. Rails has like built-in ways to handle all of that stuff. So you don't need to like extract out the salt and add it and hash it. We've got some built-in magic for that. Okay, cool. So now we know they are who they say they are. Then what happens? How do we allow them to do things that you have to be logged in to do? Any guesses?
This is where the tokens start coming in.
Yeah. So you can think of a token like a hand stamp at a club or something. It's like, yeah, I already gave my username and password. This is my token. I'm good to go. And then all we need to do is verify the token. And the tokens can expire. So like you got to get a new one every couple hours or every couple days or never. But we take their username and password. We make sure they are who they say they are. And then we issue them a token that's the same thing as like kind of it's like a substitute for their username and password. And then they're going to send us that token every time they want to do something. Cool. So let's talk about these tokens real quick. So a token, our token is probably just going to say something like user ID is whatever our user ID is. You can also put other stuff on here if you want to. You can store any data you want. And then we're going to sign it. So it's just like if I put my signature on top of this. And so then if you tried to change this, you'd have to kind of like delete my signature. It wouldn't look the same. I'd be able to tell that you screwed it up. This is exactly how cryptographic signing works also. And it has to do with, dun, 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 wait for it, hashing this. We're going to hash this so that it ends up with a signature on it. So then when they send me back that token, how do I know they didn't screw with it? How do I know they didn't just go, ah, ha, ha, never mind. It's not, my username ID isn't 3, it's 4.
They would have to, like you were saying, get rid of your signature and then apply a new signature once they change it to 4.
Yeah. Yeah, exactly. And I can hash the thing that they gave me and see if the signature is the same. Signature's not the same. They tampered with it. Hashes to the rescue. All right, so one more thing about this. So I want to send something like this, but we've already talked about how we can't just send hashes or objects or anything like that. So how do we get around that with like most data? JSON. We take it from whatever this complex data type is, and we turn it into a string. JSON is one way to do that. XML is another way to do that. And anybody who speaks those two things can take those strings and turn them back into whatever kind of complex object. That's not the only way we can encode stuff, though. Another really common way to encode things is base 64. Well, I can take that and base 64 encode it and be able to turn this cool hash into a string, turn that string back into the cool hash. So let's talk about base 64 for a second. What other base things do you know? You know base
Arabic numerals.
What was that?
Arabic numerals.
Yep.
Roman numerals.
Oop,
Binary.
Kind of. That's not. Those aren't different bases necessarily. Binary is. What's binary?
Base 2.
Base 2. What's decimal?
Base 10.
Yes. So we go 0, 1, 0, 1, 0, 1, 0, 1. That's base 2. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's decimal. Hexadecimal, so that's 16. Hexadecimal, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Anybody know what the next number is?
A.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, F. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, F. So 10 in base 16 is A. 11 in base 16 is B. We get all the way up to 15. F. 16 is what? One zero. All right, so base 64. Hui! 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, lowercase and uppercase. So 65 is 1, 0. 66, 2, 0. Just a different counting system. All right, let's see it in action. I would like you to navigate your web browser over to jwt.io and scroll down. This, oops. This and this and this are the token. Really, the header and the payload, that's our token. It's signed so that if I change whatever the payload is, it'll have a different signature. And when it's encoded, it looks like this. And it's encoded in base 64. This, come on, did it again. This pink part in base 64 looks like that. This payload in base 64 looks like that. Whatever the signature is, looks like that. 3 parts to a jot. Watch when I edit this payload, you should do this yourself. Watch how the pink part or the purple part changes. I changed John Doe to Kyle Coberly. Payload's different. I get rid of the issued at time, that's the IAT. I get rid of that. I got a shorter purple part. You usually don't mess with the headers yourself, but let's say I wanted to get rid of that. I got a shorter red part. Anybody figure out? So, okay, so all of that stuff we're just doing, that's encoding. This is an encoded version of this. This is a decoded version of this. So this word means something. We have encoding and we have hashing. I want you to think to yourself, what's the difference between encoding and hashing? Super big difference. Think to yourself for a sec. I'm going to call on someone. What's the difference between encoding and hashing? Christopher, what you got for me? Unmute, there you go.
Yep. So encoding is taking like just like regular information and turning it into just like crazy numbers, letters, all of that crazy stuff, I guess, within the base 64 way of, or like you were saying, like a counting way. And hashing, not so simple, has to do with like an object already created, maybe?
Ooh, so we got a lot of good things in there. Can anybody expand on that? We're like 60% of the way there. Can anybody get us to 80?
I feel like hashing adds that salt part. So like an unknown something added into the mix.
Yep, you would never salt like in encoding.
Okay.
But you also don't have to salt to hash. Like those signatures, these are hashed. Let's see if it'll show it. Like that's a hash. It's not salted though. Who else can help us differentiate between encoding and hashing? Take a shot.
Encoding is for maintaining like the usability, and it can be reversed. So like it's not for security, whereas hashing is not reversible. So it
Yes.
maintains integrity and security.
Encoding is reversible. Hashing is never reversible. It's the whole point of it. Think about Kyle's shitty hashing algorithm. Where to go? Where we took cab and we added it all together and got 6. 6 could be cab, 6 could also be F, 6 could also be any number of other things. Could be the letter A 6 times. All of those are cab, or all of those are 6. So we can't reverse the hash to whatever we originally had. Encoding's pig Latin. We take something that looks like this, we turn it into something that looks like this. We can go either direction equally easy. Kind of like this. You'd say you take a hash and encode it as JSON, and then decode the JSON back into a Python dictionary. You'd encode a Python dictionary as XML. You would decode the XML into a JavaScript object. That's encoding.
So encoding is more for like sending information, right?
Yep.
And
Or
then,
storing it.
okay, hashing is like verifying information.
Correct.
Okay, cool.
Nice. Thank you for explaining that.
Yeah. Or identifying it. So like, remember the GitHub hashes? Oops. This thing right here. This is a hash, but it's not secure or anything. It's just a unique identifier. It is so astronomically unlikely that 2 commits will have the same hash that we don't worry about it. Throughout all of GitHub, like there's a pretty decent chance that like this commit is unique throughout all commits every developer has made. That gives us a pretty powerful way to search them, identify them, get some confidence. It's technically possible for like 2 of these to end up being the same thing. Incredibly unlikely. So we're just playing the odds on that.
It's somewhat appropriate to compare encoding and decoding to functional programming.
Probably not. I can see why you're doing that, but like I wouldn't mind that well too deeply. I don't think there's water in it.
Okay.
Other questions about encoding and hashing? So we're going to make a token in Rails. We're going to encode it and we're going to sign it. The signature is a hash. That gives us some confidence that some miscreant didn't tamper with this. That also gives us total confidence in what this is. So if they have a token that says that they're user 3 and they have a signature that validates that, we get that token, we can trust that they're user 3. Okay, there is a security risk in that though. Can anybody pick out what it is?
If somebody leaves their token laying around, then how do we know it's someone didn't come pick it up?
Ding, 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 ding. Somebody compromises your token, they can impersonate you. I have no way of knowing that somebody stole your token. I can tell whether or not a token is valid. I can't tell unless you also give me your username and password every fucking time, whether or not like that was actually yours or somebody stole it from you. So that's part of the trade-off we're making with this. All right, enough jibber jabber. Let's figure out how we do this. So here's some steps. We're going to create a login page, or a login route. We're going to make a login controller in action. We're going to look up a user by their username. We're going to check that the password that they gave us was okay. We're going to make a token. We're going to sign it. We're going to send it. Just like yesterday, start by just watching me. All right, so I've got my cool thing that creates users. Neat. Step one was create a login route. So I'm going to go over to the router. I'm going to say anybody that makes a post request to the login route, so like /login, I would like to forward that request over to a controller called authentication and a method called login. So the first thing you'll note is that it's not create, it's not show, it's not index, it's not destroy, it's not update. We can also just do anything we want in these controllers. So like login doesn't really match REST very well. You could say like we are creating a token. It'd be like a post to token or something like that. Fuck it. It's a slightly different format called RPC. Don't worry too much about it. Any post request to login, we want to send to an authentication controller's login action. So then we want to make that controller in action. So I'm going to Rails G controller authentication. And then in that controller, I'm going to make a login action. Done. Then I want to look up a user. Nothing too crazy there. Same way that we look things up in Active Record. User.find by username params username. All right, at least one of you is going to get bit by this in the next 24 hours. Why did I say find by instead of find?
Doesn't find return the first? Wait, no.
Oh, super good guess. Not quite.
Well, because those are the params you're putting in, right?
Yep.
Username.
What would find do? Find is real.
Find.
But like, I'm not going to get what I want if I do that. So why do I have to say find by?
The only thing I'm seeing different is so this has got a key value pair for username being params username.
Yep.
Is it related to that?
Yep.
Okay.
What would the find version of it be?
It wouldn't be a key value pair. It would just
Like
be
find where?
Ooh, find where I think gives you more than one match. So that means it's going to return an array. What is find looking for?
ID.
param.
Oh, I heard it.
Params ID.
The ID. So that's looking for something like that. So we want to find by. Cool. So we've looked up a user. If we don't find a user, what does that mean?
They haven't been created.
Yep. That means there's nobody with that username. So we could put a little conditional in there if we want. If no user then we can end this conversation right here. I can send back this JSON that says something like error, no user by that name. I can give it a status of unauthorized. Questions about what I did there?
Do you still need the else in your if end?
Oh yeah, this is where like the rest of our shit's gonna go.
Cool. Yeah. So then else you're gonna have your at user equal find or
Right.
user by all or find by and then user params. Cool.
We're gonna do all the rest of our stuff that we need to do, because if that isn't true, that means there was a user. Any other questions about what I did here? All right, so if there is a user, I need to authenticate them. It's like, all right, cool. So there is that user. Is the password that they gave me the right, does that hash to the right thing for that user? So that one, we're gonna do the same thing. We'll do @user.authenticate. We got .authenticate with has secure password. That's the other thing that we got. It's a magical method that got added to every user model, .authenticate. And it takes in whatever password they gave us. So if that doesn't match, we can kick them out. Questions about that?
That dot authenticate, that is that's comparing the new hashed password to the one already in the database.
Correct. Let's the unhashed passwords, whatever they sent along with us, because they're going to send us their username and password. And this .authenticate method will take in that password, and it does all the like hashing magic with the salt and everything to tell us whether or not it's a match. I wonder if it works. So I Rails S, I head over to Postman. I just changed users to login. Right on, bud. What if I get the username wrong? No user by that name. What if I get the password wrong? Wrong password. If I get them both right, you're beautiful. Like a lot of code on the screen, but it's not a lot of logic. We look up the user. We didn't find anything. We check their password. Otherwise, we're good to go. Questions about any of this?
So you wouldn't need a model for authentication at all?
Nope. It doesn't have its own model. It's just a place that we're keeping some related logic together.
Okay.
Other questions? All
Is
right.
there any
Go
Is there any particular reason that we've got this in authentication controller instead of putting the login inside of users?
Yes. So like we can just copy paste this whole thing over to users and make it part of that. I like to think of this as being independent of the user. Like the user controller is really about managing the idea of a user resource, creating users, deleting users, listing users, all that kind of stuff. Other activities that those users might take, like I think you can make an even enough line that we don't need to clutter up that entire controller with things that are also this logic. So like if I was going to, if I did put this in the user controller, then if I was to describe what the user's controller does, I'd say it does all activities related to managing users and their authentication. Anytime you hear the word "and" when you're describing something like that, it's probably a good idea to split it out into its own thing. But there's no, that's a semantic like code organization thing. There's no technical reason you couldn't do that.
No, I mean, it makes sense. It's like separation of concerns and avoiding God classes. Like that makes sense.
All right, so let's take a look at this last part. So we got to create a token, sign it, send it. So like we could do this, which is the server giving us a high five that we got our password right, but that doesn't help us. We still need our hand stamp. So let's make a hand stamp. So we're going to make a variable called payload. And in this payload, we're just going to keep track of the user ID. Say something like @user.id. Then we need something to sign it with. This is going to be part of the hashing process. We're going to call it a secret. It's going to be any string. Like that. Now we're going to sign a token with this payload with this secret. So to do that, we need an extra package that we don't have right now. We go to the gem file. We say gem jot like that. And by the way, I'm not having a stroke or anything. That is how that's pronounced. It's not or anything like that, or JWT. It's pronounced jot. I don't know why they do that, but whatever. They didn't ask me. So we're going to add the jot gem. And just like we did with the other one, with bcrypt, we got to install that. So we will bundle install. And what that does is it gives us a class that we can use called jot, capital JWT. So I can say that the token is JWT dot, fuck. This is the problem with doing this lesson every 6 weeks, is I never remember whether it's sign or encode. So here's how I would find that out. I'd look it up in the docs. JWT gem. And documentation, womp womp. I don't want Ruby JWT. Let me see if I can find the GitHub page. There we go. Encode, JWT.encode. And then we're going to give it the payload and our secret. Like that. Now, token. Token's token, man. If I Rails S this, and try to log in. Hey, I get a token back. If I give it the wrong username, it's mad at me. Give it the wrong password. It's furious with me, bro furious. Right username, right password. I get a token. There's the header. There's the payload. There's the signature. And here's the cool thing, since it's encoding, it's Pig Latin. Like, this isn't a secret. It's signed, so like I can tell if somebody tampered with it, but otherwise, you can paste that right into the Jot website. Check it out. Has my user ID. And if I try to change that, oops, it'll get pissed at me when I send it over. We'll do that tomorrow, but it'll get huffy with you if you try to change the signature. So now I can keep track of this over in the browser. I can send that with every request, and I can use that to figure out if somebody was logged in or not. Pretty cool. Ask me some questions about this.
If you like through the Jot stuff, is that going to be the same every time you generate it, or is it still like a different series of numbers for the same information?
It's going to be, they're going to be unique because part of, let's see, actually that one might not be. Let's see if I just hit it a bunch of times. Yep, got the exact same one. So what you do instead for that is, in addition to giving it the user ID, remember that IAT? It's issued at time. And so you could do like, let's see, Ruby Jot IAT. Let me see how they're doing it. Timed now to I. There we go. So I'm going to use the built-in time class, get whatever right now is and make it an integer. And now, I can do things like expire them also. Because you can't change that IAT or you'll have a different signature. And I can see if the issued at time was past some threshold. So that's different, that's different, that's different, that's different.
Oh, thanks.
So how does the token stay with the user as they travel around the site?
Ah, such a good question. There's a couple ways you could do it. You could store it in a cookie. Or what we teach is keeping track of it in what's called local storage. So like, if I just open up some random web page, local storage dot set item my token. Well, yeah, no shit, this is insecure. I'm trying to teach the kids something. Let's see if I can do it on the Firebase site. All right, over on the Firebase site. There we go. Cool, so I've got that in local storage. I can also get it out of local storage. Now, at this point, you might be going like, cool, Kyle, you just made variables more complicated. Here's the rub on it, though. When I refresh the browser, when I hard refresh the browser, actually, I probably not hard refresh, maybe. I refresh all that stuff. Hey, it's still there. I'd sort of have a hard refresh too. So it did. So that's how I can keep track of a variable between page loads.
Gotcha. And that's where the timeout comes in, and then having to log in.
Yeah.
Cool.
Other questions about authenticating users? So we didn't get to the practice part on this, which sucks because if you haven't gone through this like twice, the chances you're going to be able to do it tomorrow are like nothing. So for part 3, get like 2 reps in on all of these things. There's just one video after another of all the things that we just did and talked about. So even if I don't get this one up immediately, like you got so many resources for this. Make sure that you've done like, under your fingers all of these things twice, because tomorrow to start off this lesson, I'm going to ask you to do all of part 1 and all of part 2 before we do this. And this one's going to be, all right, cool, you got a token. Now what? Any last questions before we break? Go. Awesome. Thank you much, everybody.